Hello, welcome to the course Python Programming for Beginners. In this lecture, as part of Matplotlib library, we will see the next concept, that is labeling plots. So here, first the labeling of axis with text, axis labels and text. In our earlier lectures, we already seen some of the programs. We labeled X and Y and title. So using set underscore X label, you can name X-axis label. Then using set underscore Y label, you can label Y-axis one. Then the entire figure you want to label it, we can use set underscore title. These are all used to add text in indicated locations. Text can also be directly added to plots using text. Okay, let us see the first example program. Axis labels and text. First, you can import Matplotlib. From that pyplot, the object is plt. You are defining some values. Mu sigma equal to 115, 15. Here mu equal to 115, sigma equal to 15. Then you are calculating x value as mu plus sigma into np.random numbers with 10,000. Then you are defining figure, axis equal to plot dot subplots with the figure standard size 5, 2.7, the layout is constrained. Then you are defining n, bins, patches equal to with the histogram combination ax dot hist. The graph type is histogram. Here we are taking x, then 50, the height, then density, true. Here face color equal to CO, alpha equal to 0.75. These are the histogram graph parameters. Then you are making x label as length in centimeters. Then y label as probability. Then the figure title we are making it as artwork lengths oblique n. This is not really whatever this label, this will be printed as the title. Then you are making text directly, you are adding text also using text method ax.text 75,0.25. So this is the text you are adding, mu value equal to 115, sigma equal to 15. Then you are defining the axis dimension 55, 175, 0, 0.3. Then grid you are making true. Grid means filled with these lines. Now let us see the output. Here you can see plot.show. Yeah, this is the title. This is X label. Now this is Y label. Now this is direct text. We added mu equal to sigma equal to. Yeah, this one is grid style. Now this is histogram. Here we have taken the values, x-axis range, then y-axis is the probability. Here it is the length in centimeters. Okay, like that you can label our plot with respect to y-axis title, and you can add text also. Let us run this program. Open your Python. This is the code what we explained. First, you can import Matplotlib. From that pyplot, then define mu and sigma values. Then x equal to combination of mu plus sigma into NP, the random numbers. Here see we used NP, but without importing NumPy, it won't work. So we have to import NumPy as NP. After importing, again you can define x here, x equal to. Okay, now x value is defined, then define the plot figure comma axis equal to with the constraint size, then define n bins and patches with histogram, a density, face color, then alpha value, then set x label. X label is length in centimeter, then set y label is the probability, then set the title of the figure, x dot set underscore title, suppose hard work length, something, whatever the calculation we used. Then set the direct text value, x dot text, the dimensionality 75.25 location. You are adding mu equal to sigma equal in that plot. Then set the axis, the values, range. Now making the grid as true, then simply see the plot. plt.show. Here you can see. This is the output of this program. Here you can see this is the title, hard work length. Here x label is length in centimeter, y label is probability. Now we added the text mu equal to 115 sigma equal to 15 using the method text. 75.25 as a position. Then this is the histogram type. Here grid, just check boxes are grid style. Okay, like that you can label our plot with all these possibilities. Here you can see some more. All of the text functions return a Matplotlib text.text instance. Just as with above lines, we can customize the properties by passing keyword arguments into text function. This is another example. Here you can see. So ax dot set x label, you are making color of that x label. Suppose my data, font size equal to 14, color equal to red. In the previous diagram, what we are having? In the previous diagram, we are having length. This is the label. Now that is changing. The x label is my data. Now you can see this is the my data, which is a x label. Font size equal to 14, color equal to red. So you can customize this one also using this method. Then the next concept as part of labeling plot annotations. We can do annotation of our graph also. We can also annotate points on your plot, often by connecting an arrow using this arrow symbol pointing to XY to a piece of text at XY text. See the program. First you can import Matplotlib, import NumPy, define figure axis equal to with subplot size. Here we are defining T with NP range of these values. Then yes, you are defining with the cost values. Then you are defining line with AX dot plot using T comma S and line width equal to 2 points. Then annotated text is added using the method annotate. We are making it as the label local max xy equal to 2 comma 1 xy text equal to the annotated arrow dimensions 3 comma 1.5. Then arrow properties dictionary of face color equal to black, then shrinking with 0.05. Then set y limits, x dot set y limit minus 2 comma 2. Now you can see the graph range, plot dot show. Here you can see. This is annotation with the arrow. We are making text. Yeah, this is the graph. This is x-axis. This is y-axis. This y range minus 2. X value 0 to 5 as per the computation. So this is annotation. So let us run this program. Yeah, till import npy. NumPy is imported. Then define figure. Define t value. T equal np dot a range of with the start end value step value. Similarly, s value with the cost values. Then defining line, the plot line, x dot plot of t comma s, line width equal to 2. Then defining annotation with the label local max, the xy coordinate position 2 comma 1, text equal to 3 comma 1.5, arrow properties, dictionary of face color black, shrink width is 0.05. Then set the y-axis limits minus 2 comma 2. Then plot dot show. Here you can see. This is the output, what we explained. So like that you can annotate. This is also possible here as part of Matplotlib. Then coming to legends. In our earlier lectures programs, we already seen some of the examples related to legends. So often we want to identify lines or markers with axis.legend. Here, let us see the following program. Import matplotlib.pyplot as plt, import numpy as np, then defining figure, comma axis equal to plot.subplots with the same standard size, 5,2.7, defining data sample data values stored in data 1 to 4 with random numbers 4 to 100. Then you are defining the plot ax.plot of np.arange, length of data 1 with data 1, label equal to data 1. Then we are defining another plot with the same combination with the data 2. Then another plot with the same computation with the data 3. Here we are taking this as D, diamond shape. Then we are defining the legend, ax.legend. Then see the graph, plot.show. Here you can see this is the data 1, data 2, data 3. Data 1, data 2, we didn't mention any style. By default, it takes line with the automatic colors. Then 3, we have defined D. So D means diamond. Here, this is the color it has taken. So this is called as legend. This is called as legend, which discriminate all the plots. Okay, this is the example of legends. Let us run this program. We already imported all this. Define figure. From this, continue. Define data 1 to 4. Then define for data 1 plot. Length of data 1, label is data 1. Then define data 2 plot with the same computation line. linear line, label is data 2, then define plot 3, the same linear, but we are taking style as D, means diamond. Even previous plots also, you want to define any style, you can define. Then call legend, ax.legend. Ax.legend. Then see the plot. Plot.show. This is the output of this program. If you want, you can maximize and see. This is the legend actually. Data 1, data 2, data 3 combination. So like that, you can label our plot with our convenience. Okay, that is about labeling plots. In next upcoming lectures, we will see other interesting topics related to Matplotlib. Till then, stay tuned for latest updates.